Welcome to this instructional video on soil model functionalities. In this video, we will walk you through each feature in our soil model, helping you understand and optimize soil health and fertility for successful agroforestry management. So, let's get started. We start by initializing the soil, and we have 4 options. There is the default, ideal if you're looking for a normal starting point. Then there is custom, and this is ideal if you have conducted a detailed soil analysis, if you know, for example, your value for soil organic carbon. If you hover on top of these metrics, you will find an explanation, and when you're using the custom option, make sure to align with the units indicated here. Then there is soil grids, and for this we will have to define GPS data. So let me do that. It's important to retrieve the soil data by clicking on the link, and here you can see that based on my GPS soil data, I have a medium soil fertility. Then the last option is setting your soil fertility. If you say I have a very fertile soil, you put it to high. If you have a degraded soil, for example, you can put it to low or even very low. Now let's have a look at a real example of a cocoa agroforestry system in Ghana, of which the soil data was known, meaning we can use the custom option, and you can see I've already set the soil data. Based on these values, you can see we have an estimated soil fertility high. Submit, and if we go to vegetation, we can see indeed we have cocoa with 2 other species, and then we go to soil and we start with total soil organic matter and soil organic carbon. And here you can see the trends, and the initial values are actually quite important. If I would change, for example, the soil organic carbon to a value 12, which also changes the estimated soil fertility, you will see that the values really change quite a lot. So the initial data is quite important. Then there is soil organic matter per type. And here you can see to what extent soil organic matter, but also litter, decompose over time and through mineralization release nutrients for plant uptake. And as the system develops, you can see that litter really has an important role in this. If, for example, I would focus even more on litter, and instead of using branches for fuel wood, I would leave them as mulch, so the fraction taken out at removal is 0. Then you will see that the contribution of litter to nutrient availability is going up. Then there are the nitrogen fluxes, and here you can see the inflows and outflows of nitrogen. Most important inflow is the soil organic matter mineralization, and outflows consist of leaching and runoff. By leaching and runoff, the NPK is permanently lost from the system, and by microorganisms uptake, the nutrients are retained in the soil but are not available to plants. There is the soil CN ratio, which is also often an indicator for soil health. And as you can see in the graph info, a low CN ratio speeds up decomposition and nutrient release, and a high CN ratio slows it down because of the microorganisms uptake. And here should be a good balance because you wish to have nutrients in the short term but also on the long term. That's why CN ratio is often used as a soil quality indicator, and if I would add a lot of biomass to the soil, for example by using compost, you will see that the CN ratio is changing. Now let's change it back and we go to the NPK fluxes per type. Here you can see the extent to which the plants are taking up nutrients compared to all the other fluxes. So besides the nutrient uptake, a lot is happening in the soil. Then here are the total fluxes, and here you see the mineral and organic NPK stock, so you can see how much of the total nutrients are actually available to plants in their mineral form. So you can see there are a lot of nutrients, but the nutrients available are very different. Then there is separated NPK, but you can ignore this because it's in the test phase, but at a certain point we wish to model NPK flows separately. And then there is the potential and actual uptake. And if we look at cocoa, we can see the cocoa is not getting all the nutrients it needs. And this leads to an NPK deficiency, which you can see here. And then based on this NPK deficiency, as well as the tolerance to a poor soil of the cocoa, and it's not very tolerant to a poor soil, you will get a certain production potential for cocoa. Lastly, there is the soil nitrogen fixation per plant, and this one is relevant when there is a fertilizer or leguminous tree present. So let's compare a scenario where we have a fertilizer tree, maybe reducing the NPK deficiency compared to the original scenario. So this is the original scenario, and then we are going to try to add a fertilizer tree instead of one of the other tree species. Here I can submit and I see indeed the nitrogen fixation of the Glycidium, and I say with fertilizer tree, I export, and let's go compare. Then looking at the soil NPK deficiency, let's see the impact, and we can actually see it's going on and off with the NPK deficiency in the scenario with and without fertilizer tree. Well, let's have a look at the yields, and here we can see the yields with fertilizer tree are slightly higher than without. And then when thinking about all the costs involved, how does the annual balance look like? And we can see, except for the peaks, the cash flow with fertilizer tree is slightly higher than without. And like this, we can compare a lot of different scenarios, for example, for using compost and even specifying the timing or optimizing the application months. We can also look at soil fertility levels, for example, looking at yields for low soil fertility and looking at yields for high soil fertility. And like this, a lot is possible. Thank you for watching.